Okay, perfect. So my name is Konrad Uebel. I'm the CEO and responsible for sales from our company, Edgar. I have a engineering and business background. Just introducing myself shortly. 15 years in spending in the energy sector, doing different projects with German utilities, with planning companies. So I'm specialized in energy infrastructure planning for renewables and gas production systems, and this is what I like you to present in combination with our software we are providing called Edgar. So I will shortly introduce my team, my company. So we are a team of 20 people, which are developing the Edgar software as a software as a service. So every issue about software is provided by us. You just log in and use the software, just as easy as that. And we are hydrogen and renewable specialists with many years of experience and expertise in doing energy projects and software development together. So we have in the field of hydrogen, we have two solutions running, successfully running by customers, some of the market leaders, which are Edgar HRS for planning of hydrogen refueling stations and Edgar Hydro for planning of hydrogen production. So what we are doing, Edgar, and I will point this out later, is not just a planning tool. We call it a decision-making tool because we keep in mind technical aspects, legal aspects, and also economic aspects, and have a very holistic approach to bring this complexity together and make it decidable. So we are located in Germany, a cradle of sustainability. So it's located between Dresden and Chemnitz. So, and what is our promise? Our promise is the optimal planning of energy systems, and how we do that, I would like to point out just a second. So, what are our services? So, we provide, as I already mentioned, software as a service for our B2B customers. So, we have three applications right now on the market, two in the field of hydrogen, I already told you. And the third one is Edgar Quartier, which is a tool for planning of aerial district heating. So it's really interesting in terms of German and also, I think, Austrian heat transformation topics. So very interesting. And so we cover heat, power, and hydrogen. This is what we are doing basically. And so we have a standard software solution you can use if the use case fits for you. Then we have also a second service, which is a customer solution. So often we develop our products further together with our customers. So we have small or very big software development projects. And there we already did some of research topics like e-fuels and things like that, so which are in the technology readiness level, not at the market stage, but in a late research stage. So this is what we can do. And also performing projects using our tools, doing consulting. So what we do here is feasibility studies, concept comparisons, and often also business case analysis for our customers, especially in the hydrogen environment, and supporting project development. So, and in my topic, I mentioned we use AI. So we use multi-objective optimization, and I just quickly want to introduce how it works if you are using Edgar. So what you can see here is, or what you can do in Edgar is you have certain project targets. We call it target functions. And I wrote some of them typical target functions I wrote down. So minimization of investments is on the x-axis. This is often a target for our customers. And a second objective could be the minimization of CO2 emissions. So what you have now here is an optimization problem to minimize both. And in the bottom left, you see here, this is the utopian solution. Why utopian? Because there are no CO2 emissions in this solution and it costs you nothing. So this is utopian, but we want to have this and we want to get as close to this solution as possible. So how we do it? You start with running a lot of simulations by defining boundary conditions for your projects, like power plant size, like offtake of hydrogen or electricity, or legal framing. And then our algorithm starts working, performing thousands of simulations in a few minutes. And then you will find a so-called Pareto front. This is the red line here. And this is the place where all the optimized solutions are placed for each of a project. So you have a split between feasible and unfeasible range. And what you can read out of Edgar's results, or the results Edgar is providing, we have a recommended solution because this is the nearest solution from the utopian, which you want to achieve ideally, to what is feasible in a technical, in an economic, and an ecological way. And you always get the edge cases, so you can have a solution with the lowest capex, but often combined with high CO2 emissions in the energy sector, or you can have a solution where you have the low CO2 emissions, but you buy it with a lot of capex. So this is the range. Edgar can provide solutions, optimal solutions, always optimal solutions. And here you see one of our projects calculating more than 10,000 simulations in a few minutes. And you see the red points is the developing Pareto front, and at a certain time it's stable, and then you will get out the solutions from Edgar for your specific business case. If you're using Hydro, you will plan hydrogen generation. So decision making for hydrogen generation. What you get out of it is a technical design and dimensioning of individual components which work ideally together to make your goals achievable. Then you have a calculation and analysis of the required power supplies. You need electrical power to make green hydrogen. So this is very interesting questions of utilities. How is the combination of the renewable assets I have to buy from the market, or I have to install in a renewable power on site? And then very decisive economic calculation and analysis of the hydrogen costs. So this comes with one click out of our tool. And of course, a fast and reliable optimization algorithm to handle this complexity. And I will show you next the plant diagram and the optimization parameters. So what you can see here, just briefly, I don't have a lot of time here. This is the left side is the electricity generation, either one on-site power generation or power generation using grid. Then you have the electrical side. You can use battery storages, for instance, to provide electricity to power consumers. And then you have the hydrogen route using electrolyzers, gas storages, compressors to deliver hydrogen at a certain pressure to your off-takers, the hydrogen off-takers. And then you see already we have some sector coupling in here because you have a certain utilization potential for instance, off-heat generation. So you can use this off-heat, waste heat to, for instance, provide off-heat for your aerial heat distribution system. And what you can see here highlighted is those are the parameters and the components our optimization algorithm can optimize. So storage capacity, power of the electrolyzer, capacity of the battery system. And as I already pointed out, the necessary power and the combination of, let's say, different production options like PV or wind power or hydropower. And what you can have with one click, you see here optimization result from Edgar Hydro. So the goal was to minimize the levelized cost of hydrogen. This is always the goal, to minimize the costs. And you have to have a restriction. You have to cover the specified minimum coverage rate of your off-takers, because this is contracted volumes of energy. So you have to be compliant to this. This is how it works. You see 960 simulations performed in 24 minutes on the cloud. And then you see here our top 5 results sorted by the levelized cost of hydrogen. Then you are able to click on these top 5 results. You see here your plant configuration. For first business case, your levelized cost of hydrogen, then the combination of electrolyzer, power storage, and the necessary power supply here, 9.5 megawatt of PV located in Frankfurt am Main, and 10 megawatt onshore contracted by a 19 megawatt contracted by a power purchase agreement. And what we can do with our newest release is that we can use the optimizer to look in our data manager. So we have a big data manager where we store the technical data, the economic data. And then you see we have a certain list of products like an electrolyzer, and you can let the optimizer choose out of our data manager your products you're interested in, and the optimizer will find out during the optimization run the perfect fitting product for your hydrogen project. And yeah, a few more screenshots. I think I'm running out of time here.
You are already running out of time.
Yes, yes. So a lot of screenshots I can show you. And last slide, and then I'm finished. So what we have done, some references. Depot filling stations done with Robert Bosch, with VNG AG. We have done train HRS refilling stations with DB Energy. We have done electrolyzers with GreenEnergy. So we have already Austrian customers, 20 megawatt electrolyzer, sorry. And together with a German utility. And for instance, together with Siemens, we looked at a synthesis of methanol. So we are quite capable of doing a lot of projects and interesting complexity stuff in the energy infrastructure systems. And thank you for your time, and sorry for the overtime here.